Welcome to Module 3, the post-Bitcoin explosion. Ethereum, smart contracts, and Layer 2s. If Bitcoin does anything, it does one thing very well. Think of Bitcoin as a basic calculator. It can send and move digital money from one point to another, but that's all it really can do. With Ethereum and smart contracts, we're effectively entering what is known as the smartphone era, where it is a substantial leap forward in technology. So again, module 3, we can look at the standards connections and all of the benchmarks that align with your particular class. As noted, some of the limits for Bitcoin, that they're very slow transactions. In the previous module, we talked about how every block is built every 10 minutes. So it's really slow. With the next great blockchain innovation, Ethereum, a block could be created every 12 seconds. When you talk about the limited smart contract support, Bitcoin, because it is so basic, has scripting as a language. And this does not allow for complex actions or throughput on this type of blockchain. You also can have high fees during really strong network traffic. There was a craze, for instance, a couple years ago on Bitcoin called ordinals, where people were actually trying to put digital art on chain, and this caused a lot of congestion. And when this happened, we saw very high fees on Bitcoin. And then, of course, it's really focused on stability, not flexibility. Bitcoin, because of its hardened surface and SHA-256 algorithm, is virtually impregnable. But that stringent security also leads to a lack of flexibility. So unlike something like Ethereum or smart contract platform, you have what's called programmability. And it gives you a lot of opportunities to build applications. So what is Ethereum? It was launched in 2015 by a Russian-Canadian computer programmer named Vitalik Buterin, as well as a core group of constituents among his friends in the early circle. But what was important is that it was a young person. So anyone who's watching this, if you're a student, who's getting to learn about the history of digital assets, or maybe you're a young entrepreneur yourself, either which way, you will see throughout this industry many young, talented people who come up with entirely new protocols and new ways of building blockchains. And Vitalik is sort of the example of this. It's a platform for smart contracts. It's fundamentally what Ethereum did that was different. Vitalik was very much in the early Bitcoin community, but he wanted something that was more programmable, that could build these smart contracts and decentralized applications, otherwise known as dApps. So when we talk about Ethereum, that's the blockchain itself. Ether is the token. So it runs on its own blockchain and it supports its own token called Ether. Now, Ether acts in two different ways. It acts both as a digital currency for transactions on the chain, and it's also considered fuel, or what is known as gas. And it's running those smart contracts and decentralized apps that you have to pay in this gas. So you might be able to pay ETH to play a blockchain game. You might use ETH for DeFi or decentralized finance services, which we'll talk a little bit about later, such as lending, staking. Or you might be able to pay ETH to mint or trade NFTs or non-fungible tokens. The great novelty with what Ethereum brought to the world, what are called smart contracts. This is, you can see in the graphic, when a condition is met, the smart contract executes based on the code, and you actually have some kind of result. So the outcome happens automatically. Smart contracts allow what is called disintermediation, or the removal of intermediaries. Many of our traditional financial systems have multiple middlemen, if you will, people who are in the middle and they're taking a small cut of a transaction. Blockchain technology just eliminates that altogether by allowing things to operate on a peer-to-peer basis. So you have self-executing agreements that are coded onto the blockchain. Smart contracts automatically enforce those rules without intermediaries. They enable transparency, they reduce fraud, and then of course they power dApps, or those decentralized applications. So some smart contract examples from the real world, you might have a bike rental solution that just uses a smart contract where you pay ETH through a QR code and the bike just executes the unlock feature, and then you can use the bike and rent it. Games, we talked early on in the very introduction about potentially owning your own Fortnite skins. One of the great advancements with blockchain technology, especially in the gaming domain, is that people own the physical assets that belong in the game. And so having ownership makes these things become tradable. You also have voting for transparent elections. There are many voting platforms where members of a DAO or decentralized autonomous organization get to vote on something and enact it on chain, and you can see which wallet voted and how. And then for real estate transactions, it eliminates the need for escrow services and reduces the risk of fraud. Even here in the state of Florida, there is a company called Propi that does everything on a blockchain basis. Now, when it comes to smart contracts, I'm not going to read every single one of these, but you can see there is a long list of both advantages and risks. We want to make sure that in the Road to Bitcoin and Beyond seminar, we're always addressing both sides to remain neutral in our stance. So some of the advantages are automation, trustless execution, transparency. Anybody can read the code, for instance, the cost efficiency, and then of course it's global access. These things can be done anywhere. And you also have a benchmark spotter here. Now, the risks, of course, is that coding could have error and bugs. It could be vulnerable, where you can find some workaround where a hacker might maliciously be able to penetrate the code somehow. You also have irreversibility. This is one of the good and bad things about blockchain. Once you do something, it's done. You can't simply go back or ask for a refund. It's only a one-way street. Oracles could be manipulated. And of course, there's no legal protections. So I've mentioned dApps a few times. What are dApps? These are decentralized applications. These are applications that run on a blockchain instead of a single centralized server. So they're decentralized, they're trustless, and they're transparent and secure. We have many kinds of dApps that exist on blockchains today. These are just a few core examples. Uniswap was the first that allowed people to peer-to-peer exchange different types of tokens that live on the Ethereum blockchain. CryptoKitties was perhaps one of the most famous first blockchain-based games that actually clogged up the Ethereum chain back in 2017. Aave is the first lending market that was available on chain where people could deposit assets, borrow against them, and then do other kinds of financial activities. And Decentraland was one of the first true metaverses, an entirely digital world that people could inhabit. Now, the problem with layer one blockchains, whether they're Bitcoin, Ethereum, or others, is that they can be slow and expensive at times. During peak mania seasons in 2021 with non-fungible tokens or NFTs, for instance, sometimes people were paying tens to even hundreds of dollars in gas to access the Ethereum blockchain. It's like a crowded highway with traffic. And sometimes the best way to get around that would be a toll road. And so the analogy here would be a layer two. Instead of an actual toll, however, you're just paying to ride on the lane that's above the actual freeway itself. So on a layer two, you have a layer one is the main blockchain itself. This is the primary layer of the foundation. And of course, this is the blockchain, the network itself. These would be things like Bitcoin, Ethereum, Solana, and these are decentralized and secure. Of course, the size could be a problem. They could be slow. They could be costly. When you're talking about scaling, you're moving to the layer two, the next layer above that. And this allows for fast, cheap transactions. Without getting too much into the technology of how this works, it delays and it packages all of the data into larger blocks that a sequencer then places down on the main chain. And the applications, of course, are user-facing. They're much more friendly. They're easy to use. They're much more responsive. They happen typically in under 1 second for finality. So there's a lot more that could be done when you're dealing with things on a layer two. So when we talk about tokenization, and this is something that's becoming a very important topic in today's day and age, you can think about tokenizing the stock market. As we see blockchains become more abundant in our world, and because of the greater security guarantees that blockchain affords, many of the assets that we trade in traditional markets, such as stocks or ETFs, are eventually going to be tokenized on chain. And so tokenization represents the ownership, but in a token form. So it may be traditional assets, like I mentioned before, but now as a token. You have 24/7 global access, for instance. So instead of trading just maybe 6 or 7 hours a day, 5 days a week. Now trading can happen all the time. You can also have fractional ownership, where you just own a part of something much bigger, like in the case of Bitcoin, where you can own a tenth or 1/100th of a Bitcoin, and you don't necessarily need to own an entire Bitcoin. The same can be said for a stock. If it's a really pricey stock that maybe costs $1,000, you could own a tenth of that stock in a tokenized form. And this allows for greater market efficiency. So the key takeaways for Ethereum is that the merge in 2022 took Ethereum from a proof of work blockchain like Bitcoin to a proof of stake network, which is a different kind of technological setup. And this reduced the power consumption by 99.9%. Ethereum has expanded blockchain technology far beyond Bitcoin's original scope because it can do so much more as a programmable layer. It introduced smart contracts and decentralized applications, something that the world had not seen before Ethereum. And then it continues to drive innovation and adoption across multiple industries that are now using Ethereum as the base economic layer. So again, if you are a teacher who is doing this as a lesson in the classroom, here are some great activities you can do with students. If you're a parent who's maybe homeschooling, you could have some great discussions with your children about these ideas. And stay tuned for Module 4.